everybody, welcome back to day number 2. So day number 2 is going to be like day number 1. We're going to have normalization, PLSQL, and a couple of other little database, table space, data storage, a couple of little Oracle specific database lectures. We'll see how far we fit that stuff in, and then we'll have a lunch, and then we'll come back from lunch, and we'll work on that second assignment that I put out on the website. So I see some of you had it on your screens as I walk through. And some of you still might be working on those queries. Don't worry about it, you'll have this afternoon to do that as well. So I'm going to allot some time, because that was really today's activity. I introduced it yesterday for those people who had finished early, but most people aren't going to start it till today. So I haven't counted it up yet, but I've received most of the emails with the 5 queries that you created yesterday, which is good. So if you haven't done that yet, you can still do it today. You can still finish it up. If you don't get through the second exercise, don't worry about it. It's the first one that's going to give you the points. So all I need is that email that with your student number and then the email with your 5 queries. Then you'll get your points for that replacement assignment. So the one today I'd like you to do, but if you don't finish it, don't get to it, it's not going to damage anything. So it's not going to ruin anything. But it's a nice activity. You might find it a bit challenging actually after you build those tables and you start running those queries. Well, start writing those queries. That will help you prepare for the final exam. So there's a good reason to do it, because I'm going to ask you questions on the final exam that say, here's a sample table, and here's a word. Which query matches what you want to do? And if you don't know how to write SQL queries, it might be a problem for you. Also, pictures of an entity relationship diagram. Tell me, what is the business rule about this? Oh, well, what do you mean? If you don't know how to read an entity relationship diagram, then you're going to be stuck with that too. So any relationship diagrams, SQL queries, pretty much the heart of the testing part of the final exam that you're going to see. You're not going to see that until August 10th, 11th weekend, so you don't have to worry about it. So not this weekend, of course. So let's see, what I'm going to cover now is lecture number 5A, and it is on PLSQL. Everything you ever wanted to know about that. So actually yesterday's lecture was kind of interesting. Towards the end of it, I talked about variables and how you can actually use variables in the SQL Plus window. That's pretty much all you can do outside of variables and substitution. You can substitute runtime, where you run a script and you put you basically put a substituted value in there so that when the admin or receptionist, whoever non-database person runs it, he or she can substitute a value in, and then that example is about buildings, and then they can find out what building and what building code was associated with whatever property or whatever thing that they wanted to do the query on. So PLSQL takes that concept of the runtime variables and the being able to substitute values in to the next level, makes it into a procedural programming language. This is used a lot actually. I don't know if I'd take a course in PLSQL, but I certainly would play around with it. It is supported in the SQL Plus window, not supported by MySQL. It's an Oracle language. So you have to basically install Oracle to get access to it, or run a simulated open source utility that's going to give you PLSQL. The PL stands for procedural programming, or procedural language, I should say. So it turns SQL into a procedural language. No, SQL still is SQL. SQL is written inside of PLSQL. So you're writing a programming language that includes the ability to use SQL statements in your programming language. So it adds a lot of functionality to the big picture. So procedural programming languages use detailed instructions. They process statements sequentially. So procedural means it starts at the top, goes to the bottom. Combines SQL commands with procedural instructions used to perform sequential processing using the Oracle database. Sequential processing, well, that means go run a query, get the results, send the results over there, do that. A bunch of tasks. So PLSQL scripts, or PL scripts I should say, I'm allowing you to automate things like backups, database backups, some utilities that get performed on databases, some standard queries that might run to produce reports for certain departments and things. So you write the script, and the PL part just gives you more capabilities, because it basically gives you a scripting procedural language as well. So variable names have to follow the naming standards of Oracle because it's working with Oracle, and it's Oracle's language, by the way. You can use reserved words like begin, number, and name and table names for the variable names. But it's not a good practice because then you get confused. If you called it students and the name of the table is also called students, you might end up with a situation where there's a lot of confusion going on. And you should make the variable names descriptive, of course, like students from database or my students or something, if it's the students that you've pulled out from a query from a database table. Use lowercase letters, separate words with underscores, and here's an idea, current underscore s underscore ID as an example. Because it's written by Oracle, developed by Oracle PL, or well, Sun, I guess now, but because it is part of, closely related to the SQL Plus window, and because it is meant to be a procedural language for Oracle SQL, it includes special things, special features of a programming language that other languages don't. As an example, there's a one-to-one matching with all the data types. We even have data types for tables and for query results. So we don't have to translate data back and forth between one language and another. We're all speaking the same language with this. That's one of the selling points, actually, because you can run a query and you can take the data out and use the data directly. If you did this in Java, you'd have to run a query, take the results back, parse the results, put it into an array or something, or assign it to a variable, then use the variables. And then the variable types don't match the data types. So you have a slight conversion that goes on, rounding issues, bunch of stuff that happens actually. So this gives you a little bit more reliable, closer relationship between the scripting language and the database language, because it's basically speaking the same language. So it's a strongly typed language. All variables must be declared prior to their use. And the syntax for declaring a variable looks like this, with a variable name and a data type. What does this remind you of? This actually sort of reminds you of queries. When you create a table name, excuse me, an attribute name, and the attribute name is current underscore s underscore ID, and it's a number 6 or integer 6 or whatever it happens to be. If you're using MySQL, it would be integer. But long story short, the declaration and the variable use is very similar to writing SQL. So people who are familiar with writing SQL have an easier time learning this language, actually. People who know how to program in other languages don't use this language very much. Well, they could, but it's a little bit harder to work with. It's really not intended for the programmer. It's intended for the person who runs queries. And it's not what I'd say a full-fledged production-style programming language either. It's more of a patch language. Write a script, patch a problem, connect two things together. So we have different data types that are supported. Scalars with referencing a single value, composites for data structures. A reference itself, which is really a pointer, and then it's a specific database item. So imagine being able to take pointers or reference variables and point to records, records and tables. So you can have a whole record. So instead of actually using a variable to represent the data, you're really using the data because you can map to it that way. Which makes it a little bit easier. And then also large binary objects, because large binary objects are supported now with Oracle. So they're supported in MySQL as well. But that large binary object, well, you can make a data type in PLSQL for it as well. So the scalar data types, we'll talk about the single value data types. Well, we have the data scalar types that associate with database items. So as you might imagine, the same data types that are available for your columns in your Oracle table are the ones that are available in PLSQL. So you're using the same data types, which is a better matching. So there's a closer match without any translation. You don't have to take a variable character and change it into a string. It's a variable character. So you get apples and apples. You also have non-database scalar types that are also supported for things that maybe that go above and beyond the capabilities of what you're trying to do with the database types. So if integers, decimals, booleans, yeah, the boolean might come in handy. I don't really see that used very much with database tables. But you can actually use a Boolean in a database attribute, in a table. We also have composite data types. Those would be ones containing more than one element, so referencing multiple data elements such as a record or a structure in C or C++. Or you can consider this more like an object as well, but this is not an object-oriented environment, it's a procedural environment. And the composite data types include records, tables, and variable length arrays, or V arrays. So tabular structure that can expand or contract as needed. So it's not working with a memory footprint that's like C. Instead, it's working with more of a scripting footprint, which is dynamic, which means that if everything is dynamic in the language, then we can have more flexibility at runtime. We can make arrays grow or shrink, and we can make better use of the technology, essentially. We also have the reference data type, as I mentioned before, very similar to a pointer, but it's referencing a data item. So the database has memory, and we're going to talk about that next, actually. And the memory is in the form of, well, a table space. And inside of the table space that you're defining, you're attaching files to it. Those files are located on secondary media. They get loaded up into memory. They get marked. So everything is pretty much running, not off the disk, but off of a virtual kind of disk that gets created from all those disk files. They get marked and they get labeled and they get organized, and then the Oracle developer can go through and see what's there and reorganize things, add more memory to it. So in essence, you're really working with a main memory kind of concept rather than a secondary storage kind of concept, versus a system like Microsoft Access as an example. Microsoft Access runs from MDB files, Microsoft database files, and you're reading and writing to a file. So all of the operations you're doing are going directly to the file. Now in an Oracle system, you have data files that are storing information, but they're all being read at the start of the database. And the database boots up, and they're becoming more virtual. So the files are storing a virtual image, and then the image gets loaded, and then you have Oracle, because then you have the storage for it, because you have something that could be bigger than the capacity held by a single disk. So if you have, let's say, a 200 gigabyte drive, let's say you have two 200 gigabyte drives. You can have 4 gigabyte, let's say, virtual disk, virtual table spaces that are created. But you have 2 files, one stored on each disk. Well, it's not 2 files up in memory, it's 1. So you combine it all together, and you need more memory, you just add another disk, increase the table space, and voila, you have a bigger image. When you turn the system off, when you take the database down correctly, it saves everything to the disk. The disks are being used for the storage, but they're just not being accessed when the database isn't running. So you just have an image stored on a disk. So it's really sort of very like a hybrid virtual machine environment, actually. And then you're, as the DBA, defining how big you're making the segments and how big you're making the storage area and all the things associated with that table space and everything that you're doing with it. And then you assign the table space to users, and then the users create database objects, and then they create tables inside of those objects, and everything works, hopefully. So assume you have, I was talking about data reference types, actually mentioning that, what we're referring is something inside of that table space, inside of that RAM. So it is, it's an interesting concept, but it's a direct read and write to a table itself and to a database item. So assume the data type of the item. So if the type is a data type of a field or an attribute versus a row type, the entire row, multiple fields. So assume it's data type of the entire row. So we have the type of the field and the row type that are considered here as well. So PL SQL program structure sort of looks like this a little bit. Here we have a declaration with variable declarations, and then we have a begin, and then we have an exception, maybe for an exception handling. And then we have an end. What is this? Kind of reminds me of Pascal, actually, with begin, end, and Pascal is another procedural language, by the way. So it's very characteristic of procedural languages, if you're familiar with the concept from a programming language perspective. Follows through to the traditional model of procedural. So in the declare section, this is where we're going to make all of our variables, and we're going to add our program statements. And I'll talk a little bit about exception handling. This is great because unlike other scripting languages that don't run in procedural fashion, you run it with an error, and then the whole thing stops. Well, with PLSQL, you can actually handle the errors a little bit better. You can handle the errors because then you can put automatic exception handling that's going to look for problems and then proceed differently depending upon what happens, rather than just putting up an SQL error or something or other onto the screen. It can recover and take an alternate route, perhaps. So the program lines, they may also span multiple text lines in the text editor. Actually, it's just like C. You can write the whole thing on one line if you wanted to. As long as you have the right sections in place, the whole thing could be on one line. So you can span multiple text editor lines, and then each line ends with a semicolon. So as long as you put the semicolons in there, it doesn't really matter if you have line returns. And the text is not case sensitive. It's keyword sensitive, but not case sensitive. And then we have comment sections that look very similar to C or C++. We have blocks of comments that are delimited with this sort of syntax. And then here's a comment that spans more than one line with the opening and the closing bracket. And then we have a single comment line that starts with 2 hyphens. So very similar to other scripting languages. There's multiple different comments styles that are supported in a particular language. So I'm wondering, where's the girl that normally sits there? The last 2 weekends in a row. Or yesterday and the first weekend. She sat there all the time. She was here like 20 minutes early. I think it's so she can plan her days off. She was here ultra early so she could take 2 full days off. Actually, there were a couple of girls here that did that, I think, this weekend. They didn't show up. No. I was just thinking about that when I saw you come in, I'm like, wait a minute, you sit here. She's supposed to sit there. Because all the students, they all sit in the same seats all the time. Like you guys all sat the same way yesterday. You guys, I mean, most of you sit the same way. So, creatures of habit. So, everyone has their own spots in the room. So. All right, arithmetic operators. PLSQL supports arithmetic expressions. So we had exponential, multiplication, division, addition, subtraction, negative, the -5. And then assignment expressions. This reminds me of Pascal again as well, the assignment operator here, the colon and the equals. And so we have variables that become assigned to new values. So it's on the left side of the assignment operator. And then the new values on the right side. So here we have student underscore name, which is going to be equal to John Miller, or student underscore name, which might be equal to current students. So we could have it assigned to a string or to an attribute that we find in a table if we want to. And then, because we have a direct compatibility between the different types. So if student name was a type that was compatible or the same type, it is a very strongly typed language. So it would have to be the same, otherwise you'd get an error that would be thrown. But, dynamic assignment. Talking about PLSQL today, which is an add-on procedural language. For those of you who came in late, we're talking about PLSQL. And you're missing your seat. What happened to your seat? I was just talking about seats a few minutes ago. That's what I said. Everyone's got thrown off because people moved around. All right, displaying PLSQL output in the SQL Plus window. So they call it an SQL Plus window because it's not only a query runner, you can run queries in there, but you can also type in PL code, and you can also do those other plus as well. The other plus would be built-in Oracle commands. Obviously, it's not going to work in your MySQL window, and this will not work because MySQL does not support PLSQL either. But there's probably some open source equivalences to it, but I have yet to find anything that's really exactly the same. SQL Developer, maybe. Well, is it a procedural language? Yeah, okay. So perhaps then there are some equivalents on the market. SQL Developer, I guess, was mentioned as one. So, but essentially, you're getting a very similar functionality, different environment. So in the PLSQL window, normally PLSQL is used inside of the Oracle utilities. for forms and reports. In fact, the developer tools for Oracle, Oracle Developer, which is actually kind of weird. They call it SQL Developer instead of Oracle Developer. Do we have Designer too? SQL Designer? No? Okay. We do? I don't know. It's just like you take all of the Oracle names and you add SQL instead of Oracle. Or instead of, you know, and that's funny actually. Because there's developer, designer, I can't remember the rest of it now, but there's a whole package. Each one of these toolkits is about $3,000 or $4,000 each per license. But they all put the word Oracle, so Oracle Developer, Oracle this, Oracle that, unless they changed the names recently, which is, they probably could have. But this is last time I worked with this was at least 10 years ago, so everything was called Oracle back then. So anyway, you'll learn PL/SQL in the SQL Plus command window if you write it normally. Unless you're going to go out and buy one of the toolkits, and the toolkits are buy one of the Oracle add-on packages that are very expensive. Command to activate the memory buffer in the SQL window is to enable output from PL/SQL programs. So you can set the environment, so you can set the server output to a buffer size, and then you can set the server output on a size, and then you can use two examples of setting the server output. And when you set the server output, you're basically creating your I/O system. You have the output, the input, and things that are happening, and so you're able to manage your memory a little bit better in the SQL Plus window. This is just SQL Plus window related. Because the window itself is meant to take in SQL commands and run it on a database. Well, if the window is going to be used for programming as well, we have to set some sort of a memory footprint to be used to read and write to. So the commands to output the data from the SQL Plus window, to get things in, to get things out of the window, well, you're just going to output, put line, and then the string. So it's kind of like CGI gateway actually. When you run a command through a CGI gateway, you're going to run an executable file, perhaps on a server, and then you're going to output through the SGI interface the HTML code that's going to include the results to be sent through HTTP protocol out to a website. Then it's kind of a pass-through. So it's a very similar old-fashioned kind of pass-through or gateway kind of approach to sending the output outside of the SQL Plus window and getting it like out into something where you're going to use it maybe in a website or another program or something. So executing a PL/SQL program in the SQL Plus window, well, that's easy. You just type in the /. So you copy a program code from Notepad to the SQL Plus window, and then you run it. So it's actually kind of easy. So you can actually make a script that opens up the file inside of the PL/SQL window and then runs it automatically. And then a person who may not be familiar with databases could sit there and just run the script. So you guys are all lucky they didn't do the attendance. So the PL/SQL data type conversion functions. So we have a toDate, a toNumber, a toCharacter. And so the toDate is a character string that converts things to a date. So a toDate of 07/14/01 would do a mask of month, day, year. The toCharacter number takes a character, turns it into a number. The number or date to character string takes and runs a toCharacter on a number. Here's a number, and here's a toCharacter on a system date that's masked with this format here. So format masking works as well in the PL/SQL Plus window. So character string functions are also available. So concatenating two strings or joining two strings or more together into a single string. So the concatenation operator looks like this. It's like the two up and down lines. So first name Sarah, last name Miller, concatenate them together and you get Sarah Miller that comes out of it. And so you can use the concatenation, put a space in between one character space here. And then you can use it as the output for the full name. So, which comes in handy because if you think about the concept, you're querying a database for first names and last names, you're not going to have them both together. So a lot of the utilities and the functions of the PL window are giving you the capabilities of going backwards. So you're going backwards from taking the data from the database that's all spread out into different tables and then putting it all back together and then using it in a more of a programming fashion versus a query fashion. So the character string function. So These are very similar to the built-in functions that we get with the query language. So we have a left trim, a right trim, a to upper, to lower function. Well, then we have slightly different syntax, but very similar functions that match the same functions as we did on the SQL query. So if we run a function on the query, then we could not have to run it on PLSQL, or we could run it in PLSQL and not run it on the query and just get the information back, depending upon how we're running the query. So it gives us more flexibility in terms of what we're doing. So the right trim removes the blank trailing spaces. Length returns the length of the characters. Upper and lower, change the characters upper and lowercase, depending upon what we're looking at. So here's another character string function that is supported. So the in string. So if we take a look at the concept, what we're doing is taking a bunch of textual data, maybe some numbers, because on the numbers we can do math to it, but on the textual data we're normally going to be looking for a string inside of a string, especially if we select star from a database where all the names are equal to something or other. Then we could, or we use a wildcard on that, we can search a string and look for matching substrings and then return the starting position. So there's a lot of string utilities in there too. So the string being searched with the string that we're looking at, the search string. And we're going to get a position that comes back out of that, because then we know where to parse the string. So we can take the information that comes out of a table, or out of a row of a table, and parse it further using the PLSQL to figure out what it is we actually want out of that. That sounds like Windows, yeah?
So, if like in the example, looking for a blank space. So if there are more than one blank space in a string, so it will just return the first position?
Yes. The position where it's found. And you can do it in a loop recursively and continue through the string and find all the white spaces. Because looping iteration is supported as well. Although it is a procedural language, it's not meant to become like a. There are some user interface capabilities to it from a command line perspective, but it's not meant to be like a full programming language, like for GUI and stuff like that. It's basically for searching through strings, searching through results, and doing something with the results. Automating the process of actually cleaning up the data or automating some sort of manipulation of the data. So here's the substring. It extracts the specific number of characters from a string starting at a given point. So start here, go to there, giving what's in between is what this is going to do. So the substring here of Sarah Miller, we'll start at number 1, and then we'll go to 5, and we get the substring out of that. So debugging a PLSQL program itself, so we have syntax errors that might happen. So it does not follow language guidelines if we have a syntax error, which means we have an error, we left off a semicolon, or we left off an equals or something. So it causes a PLSQL compiler error, which means you're going to get something from the window comes up and tells you, hey, there's an error in this. And it's usually an example of some misspelling of a reserved word, or using a function incorrectly, or leaving out a parameter, or putting the parameter in the wrong order, or something. And then we have logic error. So the program compiles correctly, but it doesn't give correct output. So in terms of locating and correcting syntax errors, you're going to isolate the line that's causing the error. So this may be before or after the line that is flagged by the compiler. Just like a regular old compiler, it's going to go through line by line and do some checking for you. You can comment out the line as it's running. One error may cause several other cascading errors, so you can rerun the program after you fix one error and see if the program actually works, because it might actually. So for logic errors, you're going to identify the output variables that have the error, and identify the input and the calculations that contributed to the error. Display the values of the inputs using dbms out commands, perhaps, and then take a break and look at it again later. Or ask another student or ask an instructor for help in terms of solving problems this way. So null values and assignment expressions. So we don't normally have null values with data in a regular programming language like C or Java. If we actually assign something a null, well, we would be doing something incorrectly, especially in Java, since, well, we can have an object equal to null. References are normally null. But in PLSQL, I'm working with databases that have null values in their columns for those attributes, and we can actually work with them. So until a value is assigned to a variable, the variable value is null. So the null concept also plays a role in PLSQL because variables are, instead of initialized to 0 if it's a number or an empty string if it's a string, it's null. So you can perform an arithmetic value on the null value, and it always returns null as a value. So we have the 3-order logic in PLSQL, the same 3-order logic that we have in SQL. So we have true, false, and unknown that also exists. So advice, always initialize variables, otherwise you'll end up with a situation where you've got something that's null, and then the null value isn't contributing to the total or to the sum or anything of that nature. There's a seat right here. If you want that one, you don't have to have that one. Alright, so here's the selection structure. See, when you get here earlier, you get the best seats. And you come later, you get the later seats. So if and end if. So I was mentioning before, we can do some iteration, we can do some flow control with PLSQL. And we can actually, what I failed to mention, or maybe I haven't mentioned it yet, you can actually write SQL statements in here as well. So you can say, if select star from something or other, it comes back with something which is going to evaluate to a true, then take those results and do something with it, or do something else. If else end, if some condition, then do something else, then end if. So then the else if also exists. So if something, else if, multiple conditions or multiple checks for different things, and then do something for each one of the multiple checks. Otherwise, end it completely. So we have comparison operators, very similar to other languages, or we're comparing a Boolean expression to come out with a true or a false. So they have the equals operator, so count is equal to 5. We have the not equals here, or the not equals here, using the same kind of thing we get in SQL actually. The greater than, the less than, greater than, or equal to. All the conditions that we see in SQL, we see in PLSQL as well. So evaluating the null conditions in an if-then structure. So if a condition evaluates as null, then it is false. So, because it's not true. We have the 3-value logic of the true, false, unknown, but we're looking for true. If it's not true, then it's false or it's unknown. So null is going to be unknown, and so the null is going to be false. So how can a condition evaluate as null? Interesting question. It uses a Boolean variable that has not been initialized. So if it's null, it means the variable wasn't initialized. So you can test for null. So it uses any other variable that has not been initialized. So if you had come back and said, well, x is going to be equal to the value in this column, the value of the column is null, and then the variable is null, so it's not going to be initialized, or it will be initialized to null. Or if there's nothing in that table, it's going to come back with null. So you can check for null, and if the variable value is null, then there's your 3-order logic. So it's true, false, and null. So you can check for not null, and then not true, and you get false. So normally people are going to check for a value, or they're not a value, or they're going to check for a true-false condition. So using SQL commands inside of PLSQL, which is one of the benefits of this language, is that you can actually write SQL statements directly in here. With other scripting languages, let's say for example PHP or JavaScript, or just pick a scripting language out there, normally you're running, or JDBC actually is a good example too, in Java, the programming language. You're running and you're saying, here's a statement, run the statement. Build the statement, run the statement, do something with the statement, execute the statement. Here you don't actually have to do that, you just write the statement. So instead of treating it like a statement that's secondary to the language, this is closely tied with the language, so you can just use it. So as an example, SQL command category. The data definition languages and the data manipulation languages. This is an older version. The current version actually supports the DDL. So can be used in PLSQL. Well, this is actually a yes now. That got changed in the current version. But it does support the DML always has and also transaction control, which means you can write in the language select something from something. You can write a create table or alter table or grant or revoke privileges inside the table, actually. Excuse me, inside the PL SQL script. So you don't have to say, here's an SQL statement, send it to the database. Instead, you're communicating directly with the database. Especially if you're using the PL SQL Plus window, you're talking to the database, so you don't have to send something to the database, open a connection, send it to the database, wait for a result set to come back. None of that stuff goes on. Instead, you just talk directly to the database. Loops. So it repeats one or more times, so one or more program statements multiple times until the exit condition is reached. So we have a pretest loop and a post-test loop. So the pretest exits condition is tested before the program statements are executed, and in the post-test, the exit condition is tested after the program statements are executed. It's kind of like the do and the do while. Do something, then you're going to have a post-test. While something exists, well, that's a pretest. And then while something, do something. So here's our loop with an exit, and we actually call it loop because it is a loop. It's very Pascal kind of in nature. So we have some program statements, and then if a condition exists, then do something else. There's some more end if, excuse me, there's an end if in here. And then more program statements, and then end the loop. So we have the start of the loop, begin loop, with no begin, just loop. Loop, end loop, which ends it for us. So you might say that the syntax is fairly straightforward. It's very like a hybrid between SQL and programming, not necessarily as programming as C or C++ or Java is. So here's a loop that does a post-test. So the pretest looks for a condition, and then it'll do it. It'll run the loop. And then here's the post-test loop, and then some program statements exit when a condition exists. And here, do something. If a condition exists, do something, which is pre. Or do something, and then if the condition exists, then post-test it. Stop doing that. Do something else. So that was the loop. So we have the while loop, which is the while condition, and then we have a loop, and then we have an end loop. So we just put a while in the beginning. We could put the while inside as we saw it here. Actually, we didn't use a while in here. We just used an end loop, and exit actually in here, and an end loop. So the while condition, loop, and then end loop. So here's the for loop. So just like, you know, in C or C++ or Java, you know, for x is equal to 1, x is less than 5, x plus plus or something. Well, here we have for counter variable x, for x, in start value to end value, 1 to 5, loop, do something, end loop. So again, it's very straightforward, I should say. Different syntax, but very kind of user-friendly in my opinion. So the database cursors, I'm actually going to talk about cursors in the next lecture that goes over memory and storage systems. But the cursor is the temporary memory that's being saved on the database, at the database location on the server, that is being read and returned when results are occurring. So if we have a result set that comes back out of a query, then it's really in the cursor that we're reading and writing to. So if I had a database out there and I said, you know, I had a table students, and I said select star from students, that's results that come back are in the cursor, and so we read and write to the cursor to perform different operations. So in PLSQL you can actually do the same. You can actually use the cursor information instead of running the query over and over again to get new results to come back, which is what you'd do in another language. You can just use the cursor. So it's a pointer to the server memory location. So it contains the information about the SQL commands in the PLSQL window. It's called the commands context area. It's what happens after we run the commands. That's where the results are temporarily held. I think of it like a caching location, actually. Programming interfaces like JDBC actually work with the cursor. So you can prepare a statement, send it over to the database, hold a value, and then it's really working with the cursor. It's just not running the query over and over again. It's just running it on the results that came back from the cursor. So in PLSQL, you can actually read and write directly to it because it's right there for you. So here's what the cursor looks like. It's on the database server. We have the memory cursor, which is this little piece of memory here, and this is the context area. We have the number of rows that were processed, and then we have the processed command statement that's saved there as well. And then we have the result set, or the active list or active set that comes out of it. So if I said, select star from students or something, then I'm going to get this kind of, this kind of table that comes out of it. We've all seen it when we run a query on your database, on your tables. But what you're not thinking about when you're doing that is actually you've got the information saved. Yes, it went to the I/O, said, okay, 5 rows, here it is. Or it gives you the result set. When it gives you the result set, it's coming out of the cursor memory. And it's still in the cursor memory, it's still cached there, because you can go back and get it again if you want to, repeat it. So we have different types of cursors. We have implicit and explicit cursors. The implicit cursor is created automatically every time you use an insert, update, delete, or select command. The database is going to do it for you anyway. It has nothing to do with PL/SQL, actually. It's a database functionality. Because when it runs the query and comes back with the results, it needs to put it someplace. Well, it's putting in a cursor. So you might as well think of it like a cached or a temporary memory location. Implicitly does not need to be declared. So far you haven't created any cursors in your programs, so in your any of the SQL work that you've done. Same concept, by the way, exists in MySQL as it does in Oracle. Can be used to assign the output of the select command to one or more PL/SQL variables. So in PL, we're using it to say, hey, this variable is going to be equal to this cursor. We have a cursor data type, actually. We can say, well, run the query. Now this is equal to the cursor. So you can save different parts. You can assign the values to the cursor and use the cursors, multiple cursors. So you can have different versions of the cursor with different results that come back. And then you can compare the cursors or do something with the cursors to further manipulate it. You can only be used if the query returns one or more record. If there's no results coming back from an implicit cursor, there's no cursor. So because you didn't get anything back, you got nothing. Implicit cursor syntax. You can say select field 1, field 2, etc. into variable 1, variable 2, whatever, from tables, whatever table that happens to be, where some search exists. So where everybody's equal to, first name is equal to something or other, or last name is equal to something or other. And then you're selecting it from, and then you're, actually this is a query, by the way, and just an ordinary query. And you're putting it into variables that you're doing in PL/SQL. So you might say that the SQL capabilities are further enhanced with PL. So you have that ability to run some interesting things where the results get put into variables automatically for you, and stuff like that. So that was the implicit. The explicit cursor is made by the programmer. You're declaring it. So it must be declared in the program declare section. So at the beginning we have declare. And then we have the program statements. And then we have an end. We have a begin and an end. So it can be used to assign the output of a select command to one or more PL/SQL variables. And it can be used if the query returns multiple records or no records at all. Because we explicitly ask for something, we're going to put it into a variable. Well, then if the variable is null, we know we didn't get a cursor back. We didn't get any results back. So using an explicit cursor, we declare the cursor, we open the cursor, we fetch the cursor results into PL/SQL, program variables, put them in program, and then we close the cursor. Because we're done with the cursor. So, does the cursor ever go away? Well, it does, actually. We have memory management that's done by Oracle. Oracle does its own garbage collection, by the way. It'll go ahead and remove some cursors it doesn't need to make room for more cursors that need to be created. So, Oracle itself manages its own memory. You can help it manage its memory. In fact, you can run what's called a coalesce that's going to go through and automatically force the garbage collector to work. So you have, as a system administrator, as a database administrator, you have commands that make the memory more efficient if you want, by combining table spaces, growing table spaces, not growing table spaces, going through and cleaning up the memory, forcing the garbage collector to go through and remove unnecessary cursors. Because if you're running on a server that's very low on memory, and the more you fill up, the more cursors you create, the longer you use the database, the slower everything's going to run. So if you want to speed things up without having to reboot it or start fresh, then you do some maintenance on it and it helps it run a little bit faster. So declaring an explicit cursor, we say declare, and then we have cursor, which is the data type actually. So it's called a cursor, and then a cursor name. And the cursor is, well then run a query. Select statements, select star from students where first name is equal to something or other. So opening an explicit cursor, we just say open this cursor we just created. So we declare the cursor, then we're going to open it. So then open it, well, what's inside of it? The query results. So you might want to say that this is sort of like pre-caching a query. Why do you want to do that? Well, what if you got a huge database of books? Maybe you're Barnes & Noble and you have a huge Pearson's Publishing database of all these books, and you want to keep all track of everything. Well, you could create a cursor of a pre-compiled, pre-run query. Now that's going to be, select star from the database where last name is equal to something or other. Here's the authors of all these books. The author's all the same of all these books, that book over there. Or maybe it's by category. You do it by category because then you're going to say, well, let's just pick PL SQL programming. And then you have all these book titles that come up under the subject area. And you're just reading and writing to the cursor. You're not running that query over and over again. So you run the query once. Query gets put into the results get put into the cursor gets assigned a name, and then you go open up the cursor and you say, okay, give me all those book people again. Well, what are those books that are by PLSQL and stuff? So here's fetching explicit cursor records. So fetch from this cursor into this variable all of the books, the PLSQL books or something. So saves you time, makes it more efficient.
So you can reuse the cursor over and over.
Oh yeah, over and over again. Instead of running the same query over and over again, and you're not passing data back and forth either. So the cursor is a piece of temporary memory that's stored right there on the database. So if you're going to run a query, put it into the memory, you just read and write into the memory. It's the efficiency you get with pointers. Because you're not going to, go ahead and create another variable and copy that value to this one, to that one. You're not copying anything all over the place. Instead, you're just going right to the memory, read and write from the memory. In a huge database environment, I don't know where this word, I don't know how they came out with this big data concept recently, but I say huge. In huge database environments, you don't want to be running queries. You can't run queries. So you take a big data class to learn how to work with a database that doesn't run queries. Because you run a query, it's okay, run the query, start the query, go to lunch, come back. Actually, better yet, come back the next day. Maybe your search results are ready for you. Tomorrow morning. Well, what if we just ran this like every month? We made a new cursor and we took the cursor information. It was a temporary caching of all the results because we wanted to know. We constantly search on something in our application and we constantly have to run this query. Let's not run the query anymore. So let's cache the results, explicitly put them into a cursor, assign the cursor to a variable, and just keep using that variable. And then every month at midnight we'll refresh it. Maybe. That way we can, take advantage of it when everybody's sleeping. Refresh the cursor information. And then, day number 2, we come back and we start still looking at the cursor. So cursor information, by the way, can get out of date. So that's one of the reasons people frown against this is because you're looking at an old query. It wasn't run instantly. When you run a query instantly and you get a fresh implicit cursor that comes back out of it, it's instant. So you can't do this for, let's say, an airline reservation system. He'll be selling the same seat over and over again, which I suspect happens anyway. But so it's data that's not changing very much. Your pre-caching results is what you're doing. So processing an explicit cursor, here's a loop. So we're going to loop through, and then we're going to exit. So loop, exit, when approach. So open the cursor, loop, fetch the cursor from this cursor name, fetch into the variables, and then exit when the cursor not found, name not found comes up. So we're done. We have nothing left, so we didn't find another record. And we're going to stop. And then we're going to end the loop and close the cursor. And then processing an explicit cursor, the cursor for loop approach, another approach to do it. So for variables, in cursor, loop, some additional processing on those statements. So for all of the authors that created PLSQL books, find one made by such and such author or something, and then go through all the results you get out of that. Much easier to do that than it is to run another query in the database. So using reference data types in explicit cursor processing. So reference data types are rows or columns, which is the other thing you can do. So instead of taking the row, doing a query, taking the results set back, taking the results and copying them into variables like in Java or something or C++, you're just going to go to the row, find the piece of data that's sitting there, and use it. Or assign that to another row type variable that might exist in the program. So you declare a row type reference variable. So you declare the name and then the cursor row type. So the row, this is the data type, by the way, because the name comes first, data type comes second. So the row type is going to be the type of data type that's associated with the row that's coming out of the cursor. And then when you reference the row type reference variable, you're going whatever my row reference dot database field name. So you take a query, let's say for example select first name, last name, address, telephone number from students where last name is equal to Hecker. I get one row that comes out if I'm only in there once. I take that row as a reference, I assign it to a variable. Then on the variable I go, my row dot first name, my row dot last name, my row dot address, my row dot, and then you're reading and writing a reference just like a pointer that's to the, so you can update it, read it, do things with it, manipulate the data without using SQL. Instead you're using an object-oriented kind of, but it's kind of object-oriented in nature, but it's not really object-oriented. It's a procedural language. So you're using more of a programming interface to that row and using it as a row data type, instead of taking the row that comes back as a result set and going, okay, so this is going to be customer's first name, customer's last name, customer's address, customer's telephone number. You have 4 different variables. Or better yet, put it into a structure maybe if you're doing C and go, well, okay, so student, first name, last name, address, and put it all inside of a structure. You're still taking it and copying it to something else. More time consuming. Not as flexible. It's just reading it right from the row reference. So explicit cursor attributes have the not found is true when there's no more rows left to fetch. You have a multiple rows that came out of the cursor. False when there was rows left in the cursor. Found is true when you have rows left in the to fetch, and false if it's the exact opposite. There's nothing left to catch. Row count is the number of rows a cursor has fetched. Is open is true if the cursor is open, and false if the cursor is closed. So it could be open or closed. And these are just things you're doing on the cursor itself. So PLSQL also, so we have the row type, which is the row. So we can represent rows as a row type that in PLSQL that works as on a row as an aggregate, kind of like it's a complex data type, so it's a structure, a record row. We can also take the table and represent the table as a data structure. So we can take the whole table. So the data structure that maintains multiple data items that are the same data type. So each table item has a key and a value. So it's like a lookup table. And then each values do not need to be sequential either. So the key values don't have to be sequential. We have a key and a value. This looks like it is sequential, but it doesn't have to be. So it's used to create a lookup table that is stored in memory to improve processing speed. Well, it's very similar to how indexes work. Indexes are created automatically, and it's a lookup table. We go to the index, we search the index to find the records we're interested in inside of the table. And then we go back to the table once we resolve the address of where it's located in the cursor. Indexes are using the cursor. Actually, indexes are stored in the cursor as they're running. So we can use the same data type and the same data structure in PLSQL, create our own. So here's a table of records. So the PLSQL table that can contain multiple values that are references by a key So you're referencing the tables. You usually need to store database records that need to be processed by some PL/SQL program. Improves performance by limiting the number of database retrievals. So you're creating your own index, essentially. So you create a table that represents the table that's out there in memory, and you search the table. And it just has the rows and the index values, essentially. So you can resolve the locations from the actual table when you want to use it. So as I mentioned before, PL/SQL has exception handling built into it. Exception handling makes it more user-friendly than, let's say, running commands in an SQL window. Because then you can, like, oh, this command failed, oh, then do that one instead. Or do that one instead, or something. Or you can figure out how you're going to route through what kind of problems you're going to have. So error handling statements are replaced in the exception. So they're placed in the exception program block. When there's a problem, it goes to the exception program block. And whatever happens in the program exception block is what's going to happen when there's an error. And so an exception handler is the program commands that provide information about the errors and suggest correction actions. So the handler is just like any other programming language. It's an error handler, exception block handler. So we have predefined exceptions in PL/SQL, so we don't have to reinvent the wheel. So common errors that give predefined names that appear instead of the error numbers. Oracle is famous for this, actually. We have these error codes that come up, Aura, dash, blah, 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 blah. And then you buy the books, and the books are like, you know, I don't know, 4 or 5, they still sell them, but 4 or 5 inches thick. Now it's all online. You just go online and you get thousands of pages of error codes that come out of there. And you look up the code and you find out what the code means, and you're still lost at that point because the code didn't make any sense, and neither did the description of what went wrong with the code. So we have some predefined exceptions that are defined for PL/SQL usage, which are translations of the codes. So too many rows, no data found, no rows were returned. A value error, an invalid number. There's a character instead of a number in there or something. And you can also create your own if you don't like the predefined ones. So exception handler syntax for predefined exceptions. When an exception name happens, then do these statements. Or when this one happens, then do this series of statements. And then when others happen, then do something else. So it's very easy, actually. Just when exception, then when, then when, then. There's like if, then. So undefined exceptions are less common errors that are not given predefined names. No Aura error code appears. So instead, the exception handler tests for the Aura error code and provides an alternative error message. Which means in this one here on the other category, you might be looking for other error codes that you might have predefined, and then you're going to put something out to the screen. Maybe it says, hey, this error happened. No connectivity or something. So predefined exceptions, the errors that will not cause a runtime error, which means the program will continue to run, but will violate business rules. Those are what's called an error in terms of a user-defined error. And a programmer creates a custom error message. So you have a better thing that says, maybe it's a rule that says, you can't, the shopping cart is attempting to check out, and there's no items in the shopping cart. The shopping cart is completely empty. Well, that should be a user-defined exception. It comes back and says, hey, your shopping cart's empty. How are you going to check out? You're not buying anything. Where the functionality would work, you'd click on checkout, and then the error would come up and put this nice little friendly message to the user. It says, hey, why don't you buy something first before you check out? Your cart's empty, which is interesting. Or let's say you're leaving the program, and now you're leaving the website, or you're leaving the area, and then you say, well, your cart still has stuff in it. Don't you want to check out? Or something before you leave. So, which they used to do a lot, but they don't do that anymore, which I'm kind of glad. Because sometimes, like Amazon I used to like put stuff in there, and I'm just saving it because I haven't decided if I want to buy it yet. But then it used to bug you every time you left. But there's stuff in your shopping cart. Like, oh, you forgot to check out. Like, no, I didn't forget to check out. I don't want to check out right now. Because I'm going to go back in and change my mind another month or so, or another week or so down the road. So nested PL/SQL program blocks. So we can take an outer script and put an inner script inside of it. We can also put exception handling and nest that in. So an error that is caught or handled or an exception that's raised in the innermost blocks will send information to the outermost blocks, and we have communication that happens all the way out to the end of the program. So an inner program block can be nested within an outer program block. So we have the outer program block in blue and the inner is in white here. It's just the same. It's just a program inside of a program. And then in terms of the exception handling in the nested blocks, if an exception is raised in the inner, then it resumes in the outer block. So we can go from the inner. So here we have an exception that is raised and handled in the inner, and then control goes out. So the program resumes here in the exception code for the outer block. Because if you're going in here and you're checking to see if there's anything in the shopping cart, and you decide, oh, there is something in here, but it's not in stock right now, it's back ordered. Then we go out to the main, we go out another level, it says, okay, we can't proceed. So then we go out to the other level and say, okay, you're back ordered. And then figure out what to tell the customer about this back order. Or maybe there's a substitute product or something that they can have instead. Or maybe there's a waiting list that they need to be put on or something. So, you know what I don't like it is when people have the shopping cart designs where you can actually put something in the shopping carts. Okay, give me like 2 seconds. And then, or actually you can start now. I think we're doing attendance right now. You can actually start and then you wait all the way till the end before they just tell you that the item is not in inventory. So, okay, we're going to take a small little attendance thing going on here.
Everybody's in here already?
Everybody's in here, yes. Who's gonna... Okay, we only have one slide left, so I'm going to finish this up. So the exception that is handled in the inner block is passed to the outer block. So the program resumes from the outer block. In this particular case, the exception got transferred, the control got transferred from the inner block exception to the outer block exception. So additional program statements would be executed at one point from the outer one as it resumes. So exception handling in nested program blocks, the exceptions raised in the inner blocks can be handled by exception handlers in the outer blocks or the inner blocks. We have options with that as well. So anyway, that was a brief introduction to the concept of PL/SQL and all the capabilities. This is obviously not a programming in PL/SQL lecture. This is more of an introduction to the language, just in case you're curious or interested in using PL/SQL for any of your database needs. It is only supported with Oracle. You cannot use it on the MySQL accounts that we have created for this class. And some of you are probably already using it, so because it's a very highly used language as well. So it replaces the need to write in regular native programming like C or C++. This has a closer relationship to the data and the data types and the database tables and the cursor and the database features. So it allows you more functionality from a data processing point of view. So anyway, I'm going to stop this lecture and because the next one's on a different topic completely.